Hello everyone, this is Achinta Medi. So this is the fourth video about chemical kinetic chapter. So in this video, I'll discuss about kinetics of third order reaction and nth order reaction. So let's start it. In this video, I'll discuss about kinetics of third order reaction. So what is third order reaction? Those reaction in which the rate of the reaction depends upon three concentration terms. Okay, so there are two cases. At the first case, the molecules are same, the three molecules are same, and in the second case the three molecules are different from each other. Okay, so first of all I will discuss about the case 1. So in this case molecules are reactants are same. Okay, so let the reactants are A plus A is giving product. So when time is 0 at the initial state, a amount of reactant will be there and there will be 0 product. When time is t, it will be a minus x, a minus x, a minus x, and here it will be x. Okay, so rate will be proportional to concentration, and here it will be 3, as there are 3 product reactants and this is third order reaction, so it will be 3. So we can write dx by dt is equal to k 3 and it will be a minus x cube. Okay, so we will write dx here, this a minus x will come here, a minus x whole cube is equal to k3, dt will be here, and when we will integrate this equation, dx a minus x whole cube is equal to k3 dt, so it will give you 2 a minus x whole square. Okay, so it will k3t plus c. Okay, so when at the initial state, when time is 0, this part will be 0 and c will be equal to 2, x will be 0. Okay, so here it will be only a square, so it will be a square. Okay, so when we will put this c value in this equation, we will obtain 2a minus x whole square is equal to k3t plus 1 by 2a square. Now we can write a minus, it will be a square is equal to k3t. Okay, so we can finally write the equation k is equal to 1 by t, and it will be 2 and a minus x whole square minus a square. Okay, so this is the final equation for rate constant for third order reaction. Half-life time, here it will be t is equal to t half and a minus x will be a by 2. Okay, we will put this value in this equation. Okay, so it will be t half, k will be here, t will be here. Okay, so we can write 2 k3, and instead of a minus x whole square we will write a by 2 whole square minus a square. Okay, so we can write
2k3 a square, it will be 4, 2 square, it will 4 here, and a square a square, 4 minus 1 3, and we can finally write this half-life time. It will be 3 divided by 2 k3 a square. So this is the final equation for half-life time. Now if we discuss about quarter lifetime for third order reaction, so here it will be time, it will be 1 by 4. Okay, and a minus x will be equal to 1 by a by 4. Okay, so the general equation is t is equal to 3 by, not 3 by, it is 1 by k 2 here, and it will be a minus x whole square minus a square. So we will put this value in this equation. So it will be t 1 by 4, 1 by 2k, and a by 4 whole square minus a square. So we can write two k a square, 4 into 4, okay, so it will give you, it will be 15, here it will be 2 k3, it is k3, and it will be a square. Okay, so we can say that t 1 by 4 is equal to 5 into t half. Okay, so you can memorize this thing for some problems to easily solve those problems. It will help you. So t 1 by 4 quarter life is this equation. This is the final equation. Okay, and the unit of rate constant for third order reaction, it will be unit of rate constant, it is mole liter square second inverse. So this is the unit. In this question, if a third order reaction is 50% completed in 10 minutes, then how much time will it take to complete 75%? 75% means quarter lifetime, and 50% means half lifetime. So as we know that this equation, t 1 by 4 is equal to 5 into t half. Okay, as we as it is given that t half is 10 minutes, so it will be 5 into 10, so we can write it is 50 minutes. Okay, so how much time will it take to complete 75%? It is 50 minutes. Now let's discuss about second case of third order reaction. Okay, so in this case the three molecules, reactant molecules, are different from each other, and those are A plus B plus C giving product. So at time 0 there will be A, B, C and 0. Okay, this is P. So when time is t, at that moment A minus x, B minus x, C minus x, here it will be x. Okay, so rate will be rate will be proportional to A, concentration of A, concentration of B, and concentration of C. So we can write dx by dt is equal to K3 A minus X, B minus X, and C minus X. Okay, we can bring this part here, so we can dx A minus X, B minus X, and C minus X. Then here it is K3 dt. So when we will integrate this equation, dx A minus X, B minus X, C minus X is equal to K3 integration of dt. Now, to simplify this integration, we will consider this part. Let A minus X, B minus X, and C minus X is equal to A minus X, and you have to write here 1 by B minus A, C minus A, and it is plus then B minus X, and here you can write A minus B, C minus B, plus C minus X here, and here it is A minus C, B minus C. So you can see that if we are writing A minus X here, so here you have to write B minus A and C minus A. That means whether you write, if you write here A, then here it will be minus from both B and C. If you write B here, then you have to minus from A and C, A minus B, C minus B. And if you write C, then it will be A minus C, B minus C. Okay, so it is easy to memorize. Next, we are going to integrate this whole part. Okay, so from this equation, when we will put this part in this equation, we will get what? As this part 1 by B minus A, C minus A is a constant part. Okay, constant, so we can write in front of integration, so it will be B minus A, C minus A, integration of this part. Here it is X, so it will be dx by A minus X. Okay, next, plus here it is 1 by A minus B and C minus B is constant part. This part is constant, so we can write in front of the integration A minus B, C minus B, integration dx by B minus X, plus this part is constant, so A minus C, B minus C, integration dx by C minus X. Here it is K3t. Okay, next, if we integrate this part, then it will give you B minus A, C minus A, and it will be ln A minus X, plus A minus B, C minus B, ln B minus X, plus A minus C, B minus C, ln C minus X, K3t. Okay. So when at the initial state, when t is 0, x will be 0. So this part x will be 0, x will be 0, x will be 0. So only 1 by b minus a, this one, and ln 1 by a will remain here. Okay, so in this case also 1 by a minus b, b minus c minus b, ln 1 by b will remain here. Okay, so in this case here it is. Okay, so when we put this value of c in this equation, then we will get, so the final equation will be k3t is equal to b minus a, c minus a, ln a by a minus x plus a minus b, c minus b, ln b by b minus x plus 1 by a minus c, b minus c, ln c by c minus x. So this is the final equation for second case of third order reaction, in which all reactant molecules are different from each other. So to memorize it, it is easy. That you can see that this part, this ln a by a minus x, is similar to the first order reaction, in which kt is equal to 1 by kt is equal to ln a by a minus x. So this part is similar to the first order reaction. Just difference is this part. If you are writing a here, so it will be b minus a, c minus a, a. Okay, we are writing a here. Okay, in this case also, just there are three reactants, so there will be a, b, c, just but similar to the first of the reaction. And here it is also ln b by b minus x, which is similar to the first of the reaction, where equation was kt is equal to ln b by b minus x, or a by a minus x, or c by c minus x. Just you have to put this b as you are writing b here, so it will be a minus b, c minus b. Here it will be b. Next, similar this, in this case c, in case of c also. So if you are writing c here, so it will be a minus c, b minus c, and this part is similar to the first order reaction. Okay, now let's discuss about kinetics of nth order reaction. So let us consider the following general equation. Okay, so n a, that means n number of reactant molecule giving product. Okay, when time is 0, a amount of reactant will be there and 0 product. And when time is t, it will be a minus x, here it will be x. So rate will be dx by dt is directly proportional to a minus x whole to the power n, or we can write dx by dt is equal to kn a minus x whole to the power n. Okay, so when we will write a minus x whole to the power n is equal to kn dt. Now we are going to integrate this equation. Dx by a minus x whole to the power n is equal to kn integration dt. So if you integrate this equation, it will give you n minus 1. You have to memorize this. When you integrate this 1 by a minus x whole to the power n, it will give you a minus x whole to the power n minus 1. So this is a mathematical equation. So it will give you kn t plus c. So initially, when time is 0, at that time x will be 0, no product. Okay, so we can write n minus 1. This equation will be x will be 0, so here it will be a n minus 1 is equal to this part will be 0 as t is 0, so here it will be c. So when we will put this c value in this equation, we will get n minus 1 a minus x whole to the power n minus 1 kn t plus n minus 1 a to the power n minus 1. Okay, so when we will put this value to here, then we will get kn t is equal to this part 1 by n minus 1, 1 by n minus 1. This is common, so we can take it common as 1 minus n 1 by n minus 1 into a minus x whole to the power n minus 1 minus a to the power n minus 1. Okay, so we can write this n minus 1. If we can write this thing as a minus x, and here it will be minus n minus 1. So minus n minus 1 we can write as 1 minus n. Okay, and here you can write this also 1 minus n. Okay, so this is the final equation for nth order reaction. Now let's evaluate the half-life time. T is t half, so a minus x will be a by 2. So in this equation we will put t half is equal to 1 by kn n minus 1, and here it is a by 2 whole to the power 1 minus n minus a to the power 1 minus n. Okay, so we can write this t half is equal to 1 by n minus 1 a to the power 1 minus n divided by kn is equal to 1 by 2 to the power 1 minus n minus 1. Okay, or we can write t half is equal to 2 to the power n minus 1 minus 1 divided by n minus 1 kn a to the power n minus 1. Here you can see that the power of 2 is n minus 1, and here it is n minus 1. So this is same, and here it will be minus 1, and n minus 1 is here, and 1 n minus 1 is here. Okay, to memorize this, I am simplifying this. Okay, so this is the final equation for half lifetime of nth order reaction. Now let's discuss about quarter lifetime for nth order reaction. So for that, t will be t 1 by 4 and a minus x will be a by 4. As we know that the general equation for nth order reaction, it is t is equal to kn n minus 1, and here it is a to the power n minus 1 minus it is a minus x, and it is n minus 1. Okay, so here we can put the a by 4 instead of a minus x. So when it will t 1 by 4, it will be k n n minus 1, and here it is a by 4 n minus 1 a to the power n minus 1. Okay, so it will give you kn n minus 1, 4 will be here, 4 n minus 1 a to the power n minus 1 minus a to the power n minus 1. So it will be a to the power n minus 1, and here it will 4 n minus 1 minus 1. So this is the equation. T 1 by 4 is equal to 1 by k naught kn n minus 1 4 to the power n minus 1 minus 1 divided by a to the power n minus 1. This is the equation for quarter lifetime for nth order reaction. Now I am going to discuss about the method of equifractional parts, half-life method. So for that, as we know that the relation between half-life time and amount of reactant, so this is the relation. T half is directly proportional to 1 by n whole to the power n minus 1, where n is the order. Okay, so if there are two half-life time, then we can compare that, or we can take the ratio t half 1 for the first case and t half 2, which is equal to a2 by a1 whole to the power n minus 1, where t half 1 and t half 2 are the half-life periods for a definite when the concentration of the reactants are a1 and a2. Okay, so when we will taking log of this equation, it will give you log t half 1 by t half 2 is equal to this n minus 1 will come to in front of the log, so it will be n minus 1 log a2 by a minus 1. Okay, so next we can take this log a by 2 to here, so we can write n minus 1 is equal to log t half 1 by t half 2 divided by log a2 by a1. Okay, so n will be equal to, as 1 is here as a negative, here it will be positive. So 1 plus log t half 1 by t half 2 divided by log a2 by a1. Okay, so from this equation we can calculate the order of the reaction. So as n is the order of reaction, we can calculate from this equation. Okay, now let's solve a problem. So in this question, the chemical reaction between mercuric chloride and potassium oxalate proceeds as. This is the reaction. The mass of HgCl2 precipitated from different solution in a given time at 100 degrees Celsius was as follows. So these are the three experiments, and the concentrations are given in different experiment, and this is the precipitated moles of Hg2Cl2. Okay, but you can see that the rate is not given, and they are asking that what is the order. So to calculate order, we have to know the rate. So first of all, we have to calculate the rate of these three experiments. Okay, so first of all, I have written the reaction. So here, this is the measure product Hg2Cl2. So for that, first of all, we will calculate the rate. A rate will be Hg2Cl2 final minus Hg2Cl2 initial. Okay, so after some time, when it was at the initial stage, let the time is 0, and when 65 minute, this is the final time, and that precipitated moles is this one. Okay, so for this three experiment, we will calculate the rates. Okay, so rate for the first experiment, it will be 0.0068 minus, as the initial is 0 and the time is 65, and here it is 10.46 into 10 to the power minus 5. Next rate for the second experiment, it is 0.0031, this one 0.0031 minus 0, and time is 120. So it will be 2.58 into 10 to the power minus 5. And rate for the third experiment, it is 0.0032 minus 0, and time is 60. So it will be 5.33 into 10 to the power minus 5. Okay, so after evaluating the rates, again I have written this table in which the concentration of reactants are there and rate is here. Okay, so by comparing these three experiments, we will say that what will be the order. So first of all, we will compare this 1 and 2. Okay, so first of all, we will compare this. Then you can see that this concentration of HgCl2 is same, 0.863, 0.836. So in this case, it is double. Okay, it is double, and the rate is almost 4 times. Okay, that means this term is indicating the, if rate is proportional to A and B, B indicating this B indicating K2C2O4 and A indicating HgCl2, and the power A and B will say the order with respect to HgCl2. A will say the order of the reaction with respect to HgCl2, and B will say the order of the reaction with respect to K2C2O4. Okay, so in this case A is constant, A concentration is constant, so A will be 0. Okay, and in this case B is double, and here this rate is 4 times, so we have to divide this. 4 by 2 is equal to 2, so B will be 2. Okay, with respect to, that means the order is 2 with respect to K2C2O4. Okay, next we will compare this two experiment 1 and 3. When we will compare 1 and 3, you can see that this concentration of HgCl2 is double, and the concentration of K2C2O4 is same. Okay, 404, but the rate is almost 2 times increases, 5.33 and 10.46. Okay, so here you can say that this is 2 times. Okay, so 2 by 2, that means 2 divided by 2, it will be 1, and here it is 4 divided by 2, so it is 2. So I can say that this is A, as this 2 is about HgCl2, so this is 1, so A is 1. Okay, so with respect to HgCl2, the reaction order of the reaction is 1, and with respect to K2C2O4, the order of the reaction is 2. So we will calculate the overall order of the reaction. We will just sum this two thing. 2 plus 1, it is 3. So order is 3. So this reaction is third order reaction.
Thank you so much for watching this video. If you like it, please subscribe my channel and share with your friends.